So on this video, we are going to be looking at medians and altitudes again and identifying them within a triangle. So we're just going to review all of the definitions real quick. So we have perpendicular bisector of a segment is perpendicular to the segment at the segment's midpoint. So that's why we call it perpendicular and a bisector. It does both. It's perpendicular to the bottom and it's the midpoint. It cuts it in half. So perpendicular bisector could be a segment, a ray, or a line. An angle bisector is a segment, ray, or line that divides the angle in half, is what that should say. That's kind of a typo. A median of a triangle is a segment that connects a vertex to the midpoint of the opposite side, of that vertex. And an altitude of a triangle is a segment that connects a vertex to the side opposite that vertex and is perpendicular to the opposite side. So we have a lot of definitions. We've been going over this for a couple of days now because this is all of the theorems that we've been learning for the last section. So we're going to classify segments inside triangles, classify the segment in each part below, only use the information given in the figure, do not assume measures are equal unless the markings indicate they are. So if necessary, you may learn what the markings are. On Alex, you can actually click on this if you don't know the markings that you're being shown. So select all that describe MN. So with this one, we just kind of want to look at MN is perpendicular to KL. We can see that here with that right angle. We can also see that it's the midpoint of KL because of these little marks here. This shows us that they're equal segments, those little tick marks. So I know that it's what we call a perpendicular bisector because it's perpendicular and it's cutting the line in half. It's not cutting an angle in half, so it's not an angle bisector. MN does not go through a vertex, so it's not a bisector, a median, or an altitude. So it actually eliminates all of these because it's not going through the vertex. Because an angle bisector has to go through an angle to bisect it. A median goes through the center and the opposite vertex. And an altitude also goes through the vertex and it goes straight down. It's not necessarily in the middle. All right, so if we look at B here, we're looking at CD. So D is the midpoint of AB. So again, I can see that with the tick marks. But I don't have any other information here. I do know that it's the midpoint. I do know that it's going through the vertex. So this is the definition for median. But it's not perpendicular bisector. It is bisecting, but it's not perpendicular. It doesn't show me that it's an angle bisector, even if it looks like it is. I can't say that it is. And it's not an altitude because it's not perpendicular to the base. And then this last one, we have QS. So I can see that it's perpendicular, but I can't see any other information. Don't assume that these are equal. They look equal to me, but don't assume that. All I can see that is that it's perpendicular. So if I have a line that's perpendicular to the opposite side going through the vertex, we call that an altitude. Okay, but it's not going to be a median. I don't know that it's in the middle. I don't know that it's bisecting the angle because I don't have any marks to show me that. It looks like a perpendicular bisector, but again, I don't have any marks to show me that. Okay, so just go with what you can see based on the marks, not what it looks like. Okay, so that's classifying segments using those bisectors or triangles. I hope that helped, and I will see you in the next video.